I'll review what we did in class for the 2x(n) games. So let's say we've got a game like this one. First, we could establish that there are no pure strategy equilibria. Note that against column A, Rose wants to play A. Rose wants to sorry. Against column A, Rose wants to play A. The right way to depict that is that arrow. Against column B, Rose wants to play C. Against Rose A, column wants to play B. Against Rose B, column wants to play A, and against Rose C, column wants to play C. So we see there's no pure strategy equilibrium. So we can also draw this game. Here. So let's first start by reproducing the matrix on this screen. Okay. Sketchpad to draw two. So what we will how we'll label this is we'll label this this line column A, this line is column B. The vertical numbers here represent Rose payoffs. Now, Rose's strategies will be sloped lines. Like Rose A will go range from 2 if column plays A to -3 if column plays B. So start labeling these lines. Rose B ranges from 0 if column plays A to 2 if column plays B. And Rose C ranges from -5 if column plays A to 10. Let's get this toolbar out of the way so I can make this line more accurate. If column plays B, -5 if column plays A to 10 if column plays B. This is Rose C. And now, so if Rose anticipates Colin's mix and best response, Rose will choose the line that's the highest at the given X coordinate corresponding to Colin's mix. So Rose can keep the game on the upper envelope of these three lines, but Colin can choose his mix to move Rose down to the lowest point on the upper envelope of these lines. So we will therefore be able to argue that this Colin's equilibrium strategy is represented by this red line. And then in equilibrium, Rose doesn't, hold on, the red line's slightly off. It needs to be intersecting right at the lowest point. There it is. And I think that will work. Okay, now I can label it carefully. Okay, that's better. And here, Rose will not play C in equilibrium because it is not a best response to Colin's equilibrium strategy. We can represent that conclusion by crossing out this row. Now, this can be solved just like any other 2x2 game. And after applying that procedure, we will have a solution to the full 3x2 game.